Hey, welcome to our fourth video on igneous rocks. Today we're going to be talking about the identification of igneous rocks, and I have a few people joining me. My name is Ms. Awad.
Mr. Baldwin?
I'm Faraz.
And I'm Neil.
Great, thanks for joining us today. So the first thing that we need to know about identifying igneous rocks is that there are two things we need to know. We need to know the composition of the rock, and we need to know the texture. And just to get us started, we're going to do a very quick review of the 9 most common minerals that are found in igneous rocks. So if you want to zoom in here real quick, we'll take a look at them. And we're going to start up here at the top with quartz. And the thing to look for when you're looking for quartz in an igneous rock is you want to look for the very glassy luster, and you want to look for this light, transparent, kind of smoky color. That's what most quartz is going to look like when you see it in an igneous rock. Second mineral you want to look for is you want to look for muscovite. Remember, muscovite is one of the micas, and it's the lighter color of the micas. And it's typically easy to see because you can still see that one direction of cleavage in the muscovite that you'll find in most igneous rocks. So you will be able to see little flakes of muscovite. The dark color mica is the biotite mica, and similar to the muscovite, you want to look for the little flakes, so in this case they'll be dark colored, brown or black, that are going to be apparent in those igneous rocks that have biotite in it. And they're going to look like little flakes, just like these little flakes that I just peeled off will look like. Okay? Moving on, we have 3 different kinds of feldspars that are present in igneous rocks commonly. The first one being potassium feldspar. And the potassium feldspar, very common in a lot of the igneous rocks. You will see this beautiful salmon color. A lot of people say it's pink or salmon color. Very typical. Look for the glassy luster again, but look for that salmon color for the potassium feldspar. We also have the series of feldspars from sodium to calcium feldspars. These are the plagioclase feldspars. The feldspars that are more sodium rich tend to be lighter color, so again you're going to look for that glassy luster and the lighter color, in this case almost a white feldspar, all the way to the labradorite, which is almost a dark gray color. Again, you're looking at the glassy luster of those crystal faces. Moving on to some of the more ferromagnesium-rich minerals, we have hornblende, which is one of the amphiboles. Hornblende is always black in igneous rocks, and a good characteristic to look for are the very long, skinny crystals that hornblende typically will have, particularly when it's in a porphyritic igneous rock. So look for the black, long, thin, columnar kind of shaped crystals when you're looking for the amphibole that's called hornblende. When you're looking for the pyroxene, which in this case would be augite, it is a very dark and dull greenish gray color. Looks very different from the hornblende. If you compare the two, it is not black, it is that dark greenish gray. And you'll notice that it looks very blocky or brick-like compared to the long, skinny hornblende crystals. So here's your augite, and here is the hornblende. And the last mineral would be olivine, and I kind of think olivine is an easy one to identify because I think of olives, which are green, and olivine is always a green color, whether it's this duller green or whether it's this more yellowy green, the 2 varieties of olivine, the forsterite and the phaolite. So those are the minerals that we're going to look for when we're identifying our igneous rocks. And now, Mr. Baldwin, you're going to do a quick review on textures.
Yes, so from our last video we saw some of the textures. So do you guys remember what the 2 textures there that we saw? The main ones?
Glassy and fragmented.
Ooh, so that was 2 of them we looked into. We also had the phaneritic and the aphanitic. Okay? So like if we looked at some of these, what type of rock do you guys remember would be these 3? Would these be aphanitic or phaneritic?
Aphanitic.
Yeah, why do you say aphanitic? You're right.
Fine grain.
Fine grain.
Yeah, real fine grains. Okay? So now if we move down towards these guys, would these be phaneritic or aphanitic?
Phaneritic.
Phaneritic. You can see the crystals in the rock, okay? And then we've got the one that's kind of in the middle. So we have two different grain sizes, and we call that being porphyritic. Two different grain sizes. We've also got one over here. Some great big crystals is the phenocryst, and then the smaller crystals that we can still see is the ground mass. So that's a porphyritic, phaneritic. Here we've got, it looks like a porphyritic aphanitic, and then two more porphyritic aphanitics. Okay? And we don't have anything else out here that's the glassy or the vesicular, but we can see that we have our textures along this side of an identification chart that we have here. Okay? So these are the different, if you can't see it, we'll have to look it up in your lab books later. But we've got our phaneritic going down to porphyritic, going down to aphanitic, and then we'll have glassy, vesicular, and pyroclastic, or fragmental. Okay? So that's one of two things that we have to start looking into when we start identifying these igneous rocks. We look into the texture, so which is like the size and the shape of the different mineral grains, and we look into the composition. So the composition is the type of minerals that are present, just like what Miss Awad pointed to us earlier. Okay? So, Miss Awad, do we want to start talking about how to locate, or how to figure out what is in each of these rocks?
Let's do it. So on our chart, this is going to be a very helpful tool for us. We're going to need to know the texture, and we're going to need to know the composition. So the composition is represented in the top portion of our chart here, and we're going to start out with thinking about whether the rock overall is a light color rock or whether the rock is a darker colored rock. And we have some special names for the lighter and the darker color rocks that will help us identify them. First of all, we're going to talk about the lighter color rocks as being felsic rocks. So we could say felsic, or sometimes called granitic, and those are rocks that contain the light colored minerals. So silicate minerals with high percentages of silica and feldspar. All right? And when we look at the minerals here, which ones, guys, would we say are the lighter color minerals?
This one.
Okay, the sodium feldspar. What else?
And the fourth one, this one might be.
Okay, the potassium feldspar. What else do you think?
This one?
Muscovite, good. And there's one more, quartz, perfect. Yep. So those are very common minerals for felsic rocks to have in them. Let's move all the way to the dark end. So let's move to the mafic rocks, and sometimes called basaltic. So mafic rocks are rocks that contain the dark color minerals that are rich in ferromagnesium. And let's take a look at our minerals again. Which minerals do we think would be present in a mafic rock? What do you think?
This one?
Hornblende, perfect.
This one?
Augite, yep.
This one?
Calcium-rich feldspar, good. What do you think about olivine?
No.
This one's a little tricky. Olivine, even though it can be this color green or even this lighter yellowy green, this is a very mafic or even ultra-mafic mineral. So that's the one that doesn't fit our pattern so well. Okay? And then we have neither light nor dark, right in the middle, intermediate. So intermediate is also sometimes called andesitic. And andesitic rocks are rocks with a composition that's someplace between basaltic and granitic, someplace between mafic and felsic. Okay? Could also be a combination of some of those things, but typically an intermediate rock doesn't have some of the most felsic minerals, and it doesn't have some of the most mafic minerals. So things like olivine would not be present in an intermediate rock, and things like quartz would not be present in an intermediate rock. Okay? So you've got felsic, intermediate, and mafic. Let's look at what we have here. Can you pick out a rock or two that you definitely think are mafic? The dark ones. What do you think?
This one?
Perfect. Yep. And a rock or two that you think are felsic.
Felsic. This one?
Yep. Good. Okay. Did you get one?
This one?
That one? Perfect. All right. And how about one that you think might be intermediate? You got it. That one?
This one?
Perfect. Okay. So it's pretty easy to categorize them into felsic, intermediate, and mafic. Now we have to try to figure out what minerals are present. One quick question. Can we do that when we're talking about aphanitic?
No.
No. Why not?
They're too small to see.
Yeah, the crystals are too small. So we're not going to ask you anything about the composition if it's an aphanitic rock. But when we're talking about phaneritic or porphyritic phaneritic, so these guys, we are going to want to talk about the minerals that are present. And that's when we're going to come to this interesting looking chart up here. So this is just a graph, really, and we have from 0 up to 100% on this y-axis. And going across this way, we're going to be looking at the different minerals that are present, okay, and how much of them is going to be in a rock. So in the felsic rocks, this is the category of felsic rocks, they are going to have muscovite, quartz, potassium feldspar, maybe some of the sodium-rich plagioclase feldspar, maybe some of the biotite mica, and sometimes a little bit of hornblende. So muscovite, quartz, potassium feldspar, plagioclase feldspar, those were the ones that you picked out as being the light minerals. Do you see a rock that has these minerals in it here? Something that definitely has those minerals. What do you see here? Let's look for the potassium feldspar a little bit. Maybe.
That one, yeah.
That one? Okay.
Yeah.
What about in the phaneritic or porphyritic phaneritic category? Do you see something that has it?
This one maybe?
That one might. Okay.
Yeah.
Another one?
This one?
Ooh, what do you think about this
Oh.
one? See these big pink potassium feldspar crystals?
Oh.
Yeah, there we go. Okay, so this is a felsic rock, and as we said before, this is a felsic rock. And we know that this rock has the potassium feldspar. We can also see some of the plagioclase feldspar in here. And if you move it around a lot, you can look and find some of these gray quartz crystals. Here's one by my finger. You can see the gray quartz in there. And sometimes on granites, if you can find another surface, you find some more pieces of quartz in there. Very glassy quartz. Okay? So that's how we're going to look for minerals within a felsic, phaneritic, or phaneritic porphyritic rock. All right? Jumping to the intermediate category, we have quartz present, some potassium feldspar, lots of plagioclase feldspar. And it tells us here it's white to light gray in color. Some hornblende, and maybe some augite. All right, so we're going to be looking for quartz. We're going to be looking for some of the feldspars. And we're going to be looking for some hornblende, these things in the rocks. So I think that's where you go, right?
Yeah.
Right in here. Good. Another rock that's typically in the intermediate category is this one. So if we take the quartz out of here and we just look at those two minerals, can you see those two minerals in that rock?
Mm-hmm. Yeah.
All right, good. All right. Then we move on to the mafic minerals. Mafic being the more calcium-rich plagioclase feldspars, so the darker feldspar, the pyroxene, maybe still a little bit of amphibole, maybe just a bit, and some olivine. All right? Those would be the mafic rocks. Now, if you take a look at this rock, can you find any of those minerals in this particular rock? What do you see in there?
A little bit of this one.
A little bit of augite?
Yeah,
Do you see
on the
anything
side
else,
over
do you
here.
think? Can you see any long, skinny hornblende crystals, maybe?
Yeah, you can tell by like the straight edges.
Okay, good. See some of them over here. So this would be a mafic rock, right?
Yeah.
Okay, great. And then the last category we have, which is our ultramafic category, and a lot of the rocks that show up in the ultramafic category would be pure olivine or pure augite, or sometimes, well, those are the two big ones. Okay, so those are our minerals that are present in each of those compositional categories. Mr. Baldwin, you want to take them through naming the rocks?
Yeah, so we're going to use a combination of both of the things we just learned. So we're going to look at composition using our table up here, and we're going to look at the texture using this part of the table down here. So the texture going from intrusive all the way to extrusive. Okay? So it's kind of like a little axis here. So we've got texture on this side, and we've got composition across the top here. Okay, so let's start with a rock and just go from there. Okay? So we've got this one. So what do you guys think is the composition? What types of colors are you starting to see in here?
Like, really...
What colors do we see from our minerals that were over here?
Like a dark salmon pink.
Okay, so dark salmon pink.
Yeah.
Okay, so we'd see this potassium feldspar, right? Okay, so if we look at our list over here, where we've got a lot of potassium feldspar, kind of a lighter pink color, we're going to be towards our felsic range. Okay, so that's our composition. So we've got this part of the axis here. Now we've got to go vertically here, so we have to figure out our texture. So what's the texture? Do you guys think this has really large crystals or really small crystals?
Small crystals.
Small. So is that phaneritic or aphanitic?
Aphanitic.
Good. So if we take a look, we're just going to follow this down until we get to aphanitic, and we get ourselves, what do we have?
Rhyolite.
Rhyolite. Perfect. Okay. Making sense so far?
That's pretty easy, guys, huh?
Yeah.
Good.
All right, you guys want to try another one?
Sure.
Okay, so let's take a look at this one. Do you guys want to do composition first or texture first?
Texture.
Texture? Okay. So what type of texture do you guys see?
A rough surface?
Well, let's look at the size of the crystals. Okay, do you see big crystals or small crystals or both?
Both.
Yeah, both. So we've got these larger crystals that are kind of like white and milky color. And in the background, that ground mass is more of like almost like a green type of a, almost gray. Okay, so we've got two crystal sizes. What do we call that?
Porphyritic.
Porphyritic, aphanitic. You jumped ahead of me. You were a step ahead. So I'm porphyritic and an aphanitic ground mass. So I've got somewhere along this line here. So now I have to figure out if it's porphyritic rhyolite, porphyritic andesite, porphyritic basalt. So how would you describe this color? Are you more pink? Are you more kind of a light gray, white, or are you towards your black?
Intermediate. Yeah.
Yeah, intermediate. Awesome. Okay. So now what we do is look for the intersection. So we've got phenocryst and aphanitic all the way down. And what do we have?
Porphyritic andesite.
Yeah, porphyritic andesite.
Andesite, okay.
Awesome. You guys have done this before, right? Okay. Ready to do one more?
Yeah.
All right, let's try another one. So, texture or composition first?
Texture.
Texture. What's my texture?
Porphyritic aphanitic.
Yeah, how do you know?
Has both small and large crystals.
Okay, so we've got
Large
these,
too.
yeah, these large phenocrysts, and then the ground mass is the really fine ones. We can't see crystals. Okay, so we're porphyritic aphanitic, so we're somewhere in here. Okay. Now, composition. What's it made of?
Potassium feldspar?
Yeah, how do you know?
Because it has like a pinkish color.
Exactly, yeah. Notice how the colors kind of match up with the different parts of the graph. Okay, so I've got a lot of this potassium feldspar. So based on that, what's the name of my rock?
Porphyritic rhyolite.
Perfect, okay. So I just look for my felsic intersecting with my porphyritic aphanitic. So I get porphyritic rhyolite.
Rhyolite, okay.
Okay. You guys feeling good with this?
Yeah.
You want to do one on your own?
Sure.
Try this one.
It looks aphanitic.
This one's kind of tough. So remember, if you look,
like that.
yeah, you sometimes have to look at all the surfaces. So do you see it's kind of like shining crystals in here? Okay, so that's going to be,
Porphyritic, yeah, aphanitic.
well, phaneritic. You should be able to see crystals here, okay? So phaneritic, so I'm going to be somewhere right here, across these ones. Okay, so now what's my composition?
Mafic?
Mafic, perfect. And the name of the rock is?
Gabbro.
Gabbro, awesome. I think you guys got this pretty well. Miss Awad, what do you think?
All right, I'm going to challenge them with a tough one here.
Nice.
We're going to do this one. Texture. What do you think, guys?
Phaneritic.
Well, let's ask ourselves this. Are the crystals big enough to identify without a microscope?
Yes.
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 Are the crystals all the same size?
No.
No. Okay, so if they're big enough to identify, it's phaneritic, and if they aren't the same size, it's porphyritic. So it's porphyritic and phaneritic. That's going to put us right here, phenocryst in a phaneritic ground mass. And then what do we think about the minerals that are present in there? What do you see?
Feldspar, quartz. Potassium feldspar.
So what do you think this rock is called? We're here, right?
Porphyritic granite.
Porphyritic granite. Perfect. Okay, good. So I think we have mastered this top portion of it, and we've got just this little tough section down here at the bottom still to go.
Forgot about those.
Yeah, these are some of the tricky ones. But we've looked at these textures already, so we're going to have an easy time with this. We don't really need to look at composition on glassy rocks because remember they don't have any minerals. We just have to look at the characteristics of them. So we have 4 rocks here, and we're going to see what we can do here in terms of their names. First of all, let's see if we can figure out which ones are glassy. You want to pick between those? Okay. Do we deal with that one first?
Sure.
All right. So this is definitely glassy. Here's our glassy category. Goes all the way across. And we kind of have one choice here, right? And it's called obsidian. Even though this is black, it has some white spots in it. Sometimes obsidian is a rusty red color with some streaks of other, maybe a lighter color gray through it. Regardless, it's going to have this glassy look to it, and that is obsidian. Okay? So that's one we did. Anything else here that looks like glassy texture, doesn't have minerals, as opposed to being ash that's gotten stuck together?
This one?
Okay. What else does that one have that's different from the obsidian? How is it different?
It has holes in it.
Has the holes in it. Do any of the other ones have the holes in it?
No. This one does.
Yeah, that one does. And remember those holes were called
Vesicular.
vesicles, so it's vesicular. So here's our texture, vesicular. Now we have 2 different vesicular igneous rocks. We have vesicular pumice, and we have scoria, or vesicular basalt. The difference is the pumice is the lighter color, lighter weight one. The scoria is very dark in color. So between these two, which do you think is the pumice and which do you think is the scoria?
This is the pumice.
Good.
And then the scoria.
Perfect. Got it. Okay, so we have our obsidian, we have pumice, we have scoria, and the last one that we need to talk about is this fragmental or pyroclastic. And this is a volcanic tuff, which is ash that's just piled up from an eruption and is stuck together. And here's our volcanic tuff. So the thing that you might notice is when you look at the andesite and you look at the volcanic tuff, they're pretty hard to tell apart, right? Sometimes a microscope will be really, really helpful. If you suspect that the rock is ash held together, maybe grab a microscope, take a look and see if you can see the difference between the crystals that are present in an aphanitic andesite versus the ash that's being held together in a tuff. Okay?
Yeah.
So we made it through the intrusive, the extrusive textures, and all of our glassy and fragmental rocks, and we talked about the compositions, we reviewed the minerals. Do you have questions?
No, not really.
Okay, good job.
We plowed through that one. That one was a big one.
It was. It's a lot of work.
Yep.
Right.
Well, thank you guys so much for your help, and we'll see you all in class, and you guys are going to be teaching this at some point, right?
Yeah.
Thanks, guys. Bye.
Have a good one, guys.